Again, there are no homework problems for section 5.3, but I'm going to do 5 quick examples here just to show you some of these problems. You can certainly work through that section if you wish to. But some of the problems ask you to convert from what I call logarithmic expression into an exponential expression. Yep, that's exactly how the book is worded. Convert to an exponential expression. So the exponential expression for this one would be 5 to the third equals 125. That's it. That's how short a lot of those problems are from section 5.3. You just need to understand that 5 comes from the base, and I make a little circle out of it. 5 to the third is equal to 125. Okay. Next one. Let's do something with fractions, because a lot of people hate fractions. If we do log of 1 over 10,000 equals -4. Okay. Now remember, this is a common log. The common log is a base of a 10. You're not going to see it written as a base, though. You just have to know that it's there. Log with no number down here. You have to assume it's a 10. So to convert this, I'm going to write 10 to the -4 is equal to 1 over 10,000. And you can confirm that on your calculator if you want to. All right, next one. Let's try converting the other way. So convert this one. 64 equals 16 to the 3/2. Convert that into a logarithmic expression. So the thing that I look at first is, what's the base? Well, the base is the 16. The base of the exponential term is going to be your base of your log term as well. Okay, so base of 16, and then I leave a little space. I put an equal sign. So I'm done with the 16. You just need to make a decision about where the 64 goes and where the 3/2 goes. So the 3/2 goes over there. The 64 goes with the logarithm. So remember, start with the base and make a little circle out of it. You'll be all right. 16 to the 3/2 is equal to -64. So that would be considered the logarithmic expression given an exponential expression. So I'll give you another one. All right. If I give you e to the -9 equals w, could you write the exponential? Well, that is the exponential. Could you give me the log expression? Well, this one has a base of an e, so you're supposed to write ln. And then that's assuming that you know that the e is there. Okay, ln, it's implied. ln already has an e as the base, so you don't need to do any little e down here. I wouldn't mark it wrong. You can do it if you want to, but you don't need it. So ln of w is equal to -9. And again, that's making a little circle here, knowing that the e is there. Okay, so the last example is straight out of your book that I would be doing in class. This is on page 344, number 100. You know, if you want to pause this and get your book out, this is where I'm getting it from. Now, on number 100, they give you an expression. They give you a function. All right, so that's the function. It says where n of a is the number of units sold, when a is the amount of spending in advertising in thousands of dollars. So part A, they ask you to find out how many units were sold when A is 1. So all you need to do is take your calculator and type it in properly. Okay, so just this one is just asking you to substitute in a 1. Just make sure you use the ln button. Okay, so that's 1,000 units. That means if they spend $1,000 on advertising, they sell 1,000 units. Part B, They're asking you to do n of 5. You're spending $5,000 on advertising. And this obviously should be bigger than 1,000. But take a second to type it in to make sure. That's going to be 1,321 units. I just rounded down. Okay. C, I would generally tell people just to skip that. You can do that on your calculator if you want to graph it. But the one I really wanted to get to was part D. It says how much would have to be spent in order to sell 2,000 units. So now they're giving you the value of n. They're saying this is 2,000 units, and they're asking you how much do you have to spend. Okay, so this is your equation. That's the equation you have to solve. You have to solve for A. Okay, so this is your first log equation. We're going to be doing a lot of these in section 5.5. But for now, it's just an equation. Okay, don't get stressed out about this logarithm. You don't have to do anything with it on the first couple steps. Just treat it like you would treat a variable. Okay, if I asked you to solve this equation, what would you do first? Don't stress out about the log. We'll deal with that toward the end of this problem. But the first step is to subtract 1,000. Hopefully that's what you were thinking. So that's 1,000 equals 200 ln of A. The next step would be to divide by 200. Okay, we're just trying to get A. We're trying to solve for A. So if we can get ln of A by itself, now we use our log properties, okay, or the log rules that were given in this section or the previous section or whichever. But at this point, all we have to do is rewrite this. This has a base of an e, and we're going to rewrite this as e to the 5th equals a. Or if you want to write a equals e to the 5th, I don't care. Okay, but this isn't the best answer. I mean, we did solve for a, but take a second to type this into your calculator, e to the 5th power, and you're going to get 148. Remember, that's in thousands of dollars. So $148,000 in advertising that will sell 2,000 units.